fuel prices are climbing again, but China is working on something much stranger than drilling for more oil. In Shanghai, a company is trying to make liquid fuel from carbon dioxide in the air, hydrogen from water, and electricity from sunlight. The ingredients sound simple, but the goal is huge: create usable fuel without depending on crude oil. China is the world's biggest crude oil importer. In 2024, it imported about 11.1 million barrels a day, which made up roughly 74% of the oil it used. So how does China's insane fuel machine actually work? And could it affect oil prices if it ever reaches full scale? The project is happening in Shanghai's Lingang area, a district China has been turning into a home for clean energy, electric vehicles, battery companies, and advanced factories. The company behind it is called Carbonology, and its new fuel line sounds strange because it begins in a place nobody usually connects with fuel: the air. Carbonology's system captures carbon dioxide from the atmosphere, combines it with hydrogen made from water, and turns those ingredients into sustainable aviation fuel. The company says the Shanghai test line is built at the 100-ton scale, which is tiny compared to the oil industry, but important for a different reason. It shows the process can move out of a lab and into an industrial setting. That is the first step in a much harder race. A normal oil refinery can process massive amounts of fuel every day. Tankers can move millions of barrels across the ocean. Airports, gas stations, ports, trucks, and factories are already built around petroleum. Oil has more than a century of infrastructure behind it. So China's machine is not competing with oil by size yet. It is competing with oil by idea. For more than 100 years, liquid fuel has usually started underground. Countries found oil, drilled it, shipped it, refined it, and sold it. Every step gave power to someone. The country with the oil field had leverage. The country buying the oil had exposure. The route between them became part of the risk. China knows that risk better than most countries because so much of its economy still depends on imported crude. That is what makes Carbonology's project interesting. It is trying to create a different fuel path, where the carbon starts in the sky, the hydrogen starts in water, and the energy can come from renewable electricity. It sounds almost too clean when said that way. The difficult part starts when you ask how air and water become something a jet engine can burn. Most liquid fuels are built mainly from carbon and hydrogen. Crude oil is useful because nature already packed those atoms into energy-rich molecules underground. Refineries do not create that energy from nothing. They take a messy natural material and separate it into useful products like gasoline, diesel, and jet fuel. Carbonology is trying to build useful fuel molecules from a different starting point. The first ingredient is carbon dioxide. There is plenty of it in the atmosphere, but it is spread out in very small amounts. So the machine has to pull large volumes of air through materials that can grab carbon dioxide and release it in a cleaner stream. That step already takes serious engineering because air is not like a smokestack. A smokestack gives you a concentrated flow of gas from one source. The open atmosphere gives you a tiny amount of carbon dioxide mixed into everything else. Once the carbon is captured, the process needs hydrogen. Hydrogen can come from water through electrolysis. A machine uses electricity to split water into hydrogen and oxygen. The oxygen can be released. The hydrogen becomes the building block that gets joined with carbon to make fuel. Then comes the chemistry that turns those ingredients into a liquid. The carbon dioxide and hydrogen have to be pushed through reactions that rearrange the atoms into hydrocarbon molecules. The goal is to produce a fuel that can fit into aviation more easily than a completely new aircraft design. This is why the title works, but it also needs the right explanation. The machine is not magically pulling finished gasoline out of empty sky. It uses carbon from air, hydrogen from water, and electricity to do the hard work. The cleaner and cheaper that electricity becomes, the more sense the fuel makes. That is why sunlight matters so much in this story. Solar power is not just decoration for a clean energy headline. It is part of the cost. If the electricity is expensive, the fuel will struggle. If the electricity comes from coal, the climate argument gets weaker. But if the power comes from cheap solar or wind, the process starts to look more useful. Aviation is one of the first places where this matters because airplanes have a battery problem that cars do not. A car can carry a heavy battery and still drive across town. A bus can run a planned route and charge at the depot. A delivery van can return to the same place at the end of the day. But a long-distance aircraft cannot simply add a giant battery without losing too much range, cargo space, or passenger capacity. Jet fuel has stayed valuable because it packs a huge amount of energy into a weight aircraft can handle. That is why a liquid alternative gets attention. If sustainable aviation fuel can be made from captured carbon and clean hydrogen, airlines may be able to reduce their dependence on fossil jet fuel without throwing away the entire aircraft system they already use. The next problem is scale. A small test line can prove the chain works. It cannot feed the global airline industry. Turning that first proof into real supply is where the story stops being strange and starts becoming difficult. Fuel prices feel personal because most people notice them at the pump, but oil reaches far beyond the family car. It moves airplanes, cargo ships, trucks, mining equipment, farm machines, and military vehicles. It also feeds chemical plants that make plastics, solvents, and materials people use every day without thinking about oil at all. That is why replacing oil is harder than replacing one engine. Electric cars can handle many daily trips. China already understands that part. It has pushed EVs faster than almost anyone, built huge battery supply chains, and turned electric vehicles into a normal part of its car market. But some machines still need fuel that is easy to store and powerful for its weight. A ship crossing the ocean needs energy for weeks. A plane flying long distance needs fuel that does not make the aircraft too heavy. A remote mine or military operation may not have easy charging. A chemical plant may need carbon-based inputs, not just electricity. Those are the places where oil keeps its grip. Synthetic fuel tries to loosen that grip from a different angle. Instead of asking every plane, ship, and factory to change at the same time, it tries to change where the fuel comes from first. That is why governments are paying attention. Europe has already started requiring aviation fuel suppliers to blend sustainable aviation fuel into the fuel supply, beginning with a small percentage and rising over time. For airlines, that creates a problem with a deadline attached. They need cleaner fuel, but the world does not yet produce enough of it at a low price. Traditional sustainable aviation fuel can be made from waste oils, fats, and other feedstocks, but those supplies are limited. There is only so much used cooking oil in the world. There are only so many waste materials that can become fuel without creating new problems somewhere else. Fuel made from captured carbon and clean hydrogen has a different ceiling. Carbon dioxide is everywhere. Water is widely available. Renewable electricity can be produced in many places. The hard part is not finding the ingredients. The hard part is building machines that can turn those ingredients into fuel cheaply enough. China has a reason to believe it can attack that problem. It has already done something similar in other industries. Solar panels were once expensive. Batteries were once far more limited. Electric cars once felt like products for wealthy early adopters. China helped push all three into a much larger, cheaper, more competitive world. Fuel is a tougher target, but the pattern is familiar. Start with a technology that looks expensive and early. Build factories around it. Push the cost down. Use government support, local demand, and industrial scale to make the machines better. That is why the Shanghai fuel line should not be judged only by how much fuel it makes today. The real question is whether China can turn the machine itself into an industry. Hydrogen is the part that ties most of this together. A fuel from air machine needs hydrogen to combine with captured carbon. Green ammonia needs hydrogen. Some industrial processes may need hydrogen. Even energy storage can use hydrogen as a way to hold power from solar and wind when the grid does not need all of it right away. This is why the outlier talks about more than one breakthrough. The stronger story is not that China has a random list of clean energy machines. The stronger story is that many of these machines depend on the same few ingredients: clean electricity, water, air, and industrial equipment. Ammonia is a good example. Most people know ammonia as a sharp cleaning smell, but it is one of the most important chemicals in the world because it is used to make fertilizer. It can also carry hydrogen in a form that may be easier to move than pure hydrogen gas. If ammonia can be made with clean hydrogen, it could help reduce emissions from fertilizer and possibly give shipping another future fuel option. Energy storage has its own job. Solar power rises during the day and disappears at night. Wind can produce too much power at one moment and not enough later. Storage systems give that extra electricity somewhere to go, so clean power becomes more useful after the sun sets or the wind drops. Fusion belongs in a different category because it is much further away from normal use. China's experiments may be impressive, but fusion is not ready to power homes, airports, or fuel plants tomorrow. Still, the reason it appears in the same conversation is simple. If the world ever gets cheap, steady, clean electricity from fusion, fuel-making machines become easier to imagine at large scale. For now, solar, wind, storage, and hydrogen matter more. The Shanghai fuel machine needs those pieces around it. Capturing carbon dioxide takes energy. Splitting water takes energy. Making fuel takes energy. A country that wants to make fuel without oil also has to build the power system behind the fuel. That is where China may have an advantage. It is already one of the biggest builders of clean energy hardware in the world. It has massive manufacturing capacity, large domestic demand, and a government willing to push strategic industries for years before they become fully mature. But even with all of that, the math is still brutal. The machine can be real and still be too expensive. Cost is the part that cuts through the excitement. Fuel from air works only if every major step becomes affordable. Direct air capture has to get cheaper. Electrolyzers have to get cheaper. Renewable electricity has to be cheap and available in huge amounts. Fuel synthesis plants have to grow from test lines into real industrial facilities. Oil does not have to solve those problems because its system already exists. Wells are already drilled. Tankers are already sailing. Refineries are already built. Airports already know how to store and pump jet fuel. The world has spent more than a century making oil easy to use, even when it is politically risky and environmentally damaging. A new fuel pathway has to fight its way into that world. That is why a fuel from air machine will not lower gasoline prices next month. It will not stop an oil shock caused by war, a shipping crisis, or a production cut. It will not replace the millions of barrels China imports each day. The scale is not close yet, but early-stage technologies often look too small right before the serious money arrives. Solar once looked too expensive. Batteries once looked too limited. Electric cars once looked like a niche. Then factories got larger, competition increased, and prices moved. Fuel from air has not earned that comparison yet, but China is trying to find out if it can. The International Energy Agency has said e-fuels could help sectors like aviation and shipping, but only with a massive expansion of cheaper renewable electricity and lower electrolyzer costs. That is the reality behind the whole story. The fuel is only as strong as the system behind it. If clean power stays expensive, the fuel stays expensive. If hydrogen is expensive, the fuel is expensive. If carbon capture remains costly, the fuel will need policy support, premium buyers, or special markets to survive. That sounds like a weakness, and it is. But it is also the reason China is interested. A country that can build the cheapest equipment, the biggest supply chains, and the fastest factories gets a chance to shape the market before everyone else catches up. That is what makes this more than a fuel story. It is an industrial race. So could this affect oil prices if it reaches full scale? Today, no. A small Shanghai test line cannot move a global market built on millions of barrels a day. Oil prices are pushed around by wars, shipping routes, OPEC decisions, refinery problems, demand, inventories, and fear. One machine does not compete with all of that overnight. But oil prices also depend on what the world believes future demand will look like. If airlines, ships, and heavy industries have no serious alternative, oil keeps its power. If synthetic fuel becomes cheaper and more available, even slowly, some of that future demand begins to look less certain. That is how the pressure starts. Not with oil disappearing, but with oil losing some of the places where it used to have no real competition. The first effects would likely be narrow. Airlines facing sustainable fuel rules may buy more alternatives. Governments worried about energy security may support domestic fuel production. Countries without major oil reserves may look at fuel from air and see a way to reduce how much money leaves their economy every time energy prices spike. Over time, those small markets can become bigger if the machines improve. China is chasing that possibility because it has more to gain than most countries. It imports enormous amounts of crude oil. It wants more control over its energy future, and it already knows how powerful manufacturing can become when a new industry starts to scale. The machine in Shanghai is still small. The fuel is still expensive. The path ahead is still full of problems. But the direction is worth watching because it challenges an old assumption that liquid fuel must begin with oil pulled from the ground. If China can prove that some fuel can be made from air, water, sunlight, and industrial machinery, then oil faces a new kind of rival. Not a rival that replaces it tomorrow, and not one that makes fuel cheap right away, but one that changes what countries can build when prices rise and supply routes become risky. That may be the real impact. The next time fuel prices surge, the answer may not only be drilling more oil, buying more crude, or waiting for the market to calm down. It may be building more machines that make fuel from the sky.